Hi students, I am Prasad Babu, Senior Maths Lecturer in Narayana Educational Institutions. Today we will discuss JEE Main 30th date 2023 Shift 1 Maths paper. Here these questions are memory based questions. There is some vocabulary change or some numerical changes are also there to the original paper. Now coming to the first question, given here tan 15 plus 1 by tan 75 plus tan 195 plus 1 by tan 105 is equal to 2a, then the value of a plus 1 by a. So first you have to simplify this tan 75, this is nothing but cot 15, and a tan 195, this is tan of 180 plus 15, this is tan 15 because it is third quadrant, tan positive, tan 105, this is tan of 90 plus 15, this is minus cot 15. Now the given equation tan 15 plus 1 by tan 75, nothing but 1 by cot 15, that is tan 15 only, plus tan 195, that is tan 15, plus 1 by tan 105, tan 105 is minus cot 15, 1 by minus cot 15 become minus tan 15. This is 2a. So tan 15 cancel. So from this we get a is equal to tan 15. Now a plus 1 by a, that is tan 15 plus 1 by a is cot 15, and tan 15 is 2 minus root 3, and cot 15 is 2 plus root 3, that is 4. That is second option. And coming to second question, how many 4-digit numbers which are divisible by 15 can be formed using the digits 1, 5, 3 and 2? Repetition of the digits is allowed. We know a number is divisible by 15 if it is divisible by 3 and 5. A number is divisible by 5 if the units place contains either 0 or 5, but among the given digits last place or units place is filled with 5 only. Now after filling the units place with 5, we have to select remaining 3 places from 1, 2, 3, 5, so that the sum of these 4 digits is a multiple of 3. Now already units place is filled with 5 na? That's why these 3 places sum is 4, that is the least sum, so that the sum of the 4 digits is a multiple of 9. So select the 3 digits with repetition allowed, so that the sum of the first 3 is 4, so that 4 digit sum will be 9. So only one case is there, that is 1, 1, 2, and these 3 we can interchange it in 3 factorial by 2 factorial ways, because 1 is repeated 2 times. And coming to the next case, I am taking sum, first 9 over, next 12, sum of the 4 digits sum is 12. Already units place is 5, so remaining 3 places sum is 7. So what are the possible ways of filling the first 3 places so that you get sum is 7? The first one is 1, 3, 3. and this we can interchange in 3 factorial by 2 factorial ways, because 3 repeated 2 times. And another possible way to get sum 7 is, it is 2 to 3. This we can interchange in 3 factorial by 2 factorial ways, that is 3 ways. And one more possibility is there, that is 115. This we can interchange it in 3 factorial by 2 factorial ways. This is the second case. And coming to the third case, first case, sum 9, 4 digit sum. Second case, sum 12, now sum 15. Already last place is 5, na? Remaining 3 places sum must be 10. That is possible if you take 2, 3, 5. This we can interchange it in 3 factorial ways, that is 6 ways. This is the only case here, so that the sum of the 4 digits is 15. Next we have 18, that is the next multiple of 3. This is case 4. Sum 18, na? So the first 3 places is filled using that 1, 2, 3, 5, so that the sum is 13, that is 3, 5, 5. This we can interchange it in 3 factorial by 2 factorial ways, that is 3. Now the total number of 4 digit required 4 digit numbers. Required 4 digit numbers. Three plus 3, 6 plus 3, 9 plus 3, 12, 18 plus 3, 21. So there are 21 4 digit numbers that are divisible by 15 using the digits 1, 2, 3, 5 when repetition is allowed. Now moving to the next question, find coefficient of x power 301 in the series 1 plus x whole power 500 plus x into 1 plus x whole power 499 plus x square into 1 plus x whole power 498 plus and so on plus x power 500. First to simplify the given series, after that you have to find out x power 301 coefficient. Here given series is in GP. Given series is in GP with first term 1 plus x whole power 500, common ratio x by 1 plus x. When you multiply first term with x by 1 plus x, you get the second one. Second with x by 1 plus x, you get the third one, and so on. And the number of terms in this GP is 501. First you start with 1 plus x whole power 500, and the last one is 1 plus x whole power 0. So 0 to 500 we have 501 terms are there. Now the given series is sum to n terms in GP formula, a into, this is a, r power n, r is 1 by x by 1 plus x whole power 501 minus 1 by r minus 1, a into r power n minus 1 by r minus 1. If you simplify this, we get 1 plus x whole power 501 minus x power 501. Now we want coefficient of x power 301. Na? We know that 1 plus x whole power and expansion, x power r coefficient is NCR. That's why in this coefficient of x power r, x power 301 is 501 C 301. This is n, this is r, this is NCR. 501, C 301. Coming to the next question. Larger area bounded by the curves y square is equal to x, x is equal to y, and x is equal to 2. Y square is equal to x is a parabola with vertex origin. This is the parabola y square is equal to 4ax, and y is equal to x is a straight line passing through origin. This is a straight line passing through origin. Y is equal to x, and it makes an angle 45 degrees with x axis. And this y square is equal to x and y is equal to x. These two are intersect at origin and at 1, 1. Just solving y square is equal to x and y is equal to x, you get the point of intersection. And x is equal to 2. It is a line parallel to y axis and is at a distance of 2 units from y axis. Now, there are two regions here bounded between these three curves. One is this one and another one is this. This is the region bounded by parabola line y is equal to x. This is parabola and x is equal to 2. This is also that region, but we want larger region, that's why this one. So, this we get, observe here, this region is the region bounded by this parabola, total parabola between 0 to 2, that will give that upper portion. See here, required area is area of the upper portion first, that is above x axis, that is area bounded between the parabola between the lines x is equal to 0 and x is equal to 2. I have to exclude this portion. This is the portion bounded by parabola and the line y is equal to x. So, this portion is integral 0 to parabola y square is equal to x na root x dx. This is 0 to 2 root x dx. This portion you have to delete na. This is the portion between 0 to 1 parabola minus the line, that you have to delete from this, minus integral 0 to 1 root x minus x. Y is equal to x is the line, y is equal to root x is the parabola. And coming to this portion, this is 0 to 2 parabola with x axis. So, that is why just double this one. Now, simplify this one. This is 2 into integral of root x is x power 3 by 2 by 3 by 2 between the limits 0 to 2 minus this is x power 3 by 2 by 3 by 2 minus x square by 2 limits 0 to 1. This is 4 by 3 and substituting upper limit we get 2 power 3 by 2, nothing but 2 root 2, lower limit it will be 0 minus substituting upper limit it is 2 by 3 minus 1 by 2 and lower limit it is 0. So, this is 8 root 2 by 3 minus 1 by 6. This is the area of the region bounded by this parabola, this line and the line x is equal to 2, that to larger portion, this portion. Actually, one more portion is there, that is smaller one. And coming to the next one, evaluate limit extending to 0, 48 integral 0 to x t cube by 1 plus t power 6 dt by x power 4. If we substitute x0 in the numerator, we get numerator 48 into integral 0 to 0. Numerator becomes 0 and the denominator is also 0. So that's why it takes 0 by 0 form. Limit extending to 0, 48 into integral 0 to x t cube by 1 plus t power 6 dt by x power 4. So this takes 0 by 0 form. Applying L'Hospital rule, differentiate numerator as well as denominator. Derivative of numerator, it is a derivative of definite integration, you have to use Leibniz rule. So the derivative become 48 into x cube by 1 plus x power 6. This is numerator derivative. And coming to denominator, derivative of x power 4 is 4x cube. Here x cube cancel. So it become limit extending to 0. 48 by 4, 12 by 1 plus x power 6. As extending to 0, it is 12. This is the value of the limit. It's a very simple question. Coming to the next one. A special die has number 0, minus 1, minus 2, 2, 3, 4 on its faces. If it is tossed 5 times, then find the probability that the product of numbers on the dice is positive. Here we are tossing this 5 times. The product of 5 numbers is positive if all the 5 numbers are positive, 3 positive, 2 negative, then also the product of 5 positive, and 1 positive, 4 negative. In that case also all the 5 numbers are positive. So possible cases are 5 positive or 3 positive, 2 negative or 1 positive, 4 negative. So we have to select the 5 like this. All 5 positive, 3 positive, 2 negative, 1 positive, 4 negative. Given numbers 0, minus 1, minus 2, 2, 3, 4. The positive numbers are 2, 3, 4. That's why the probability of selecting a positive number is 3 by 6. And selecting negative number, total negative numbers are 2 here, minus 1, minus 2. The probability of selecting a negative number is 2 by 6. So the required probability now become, to get 5 positive, each positive number has probability 3 by 6. We have 5 such. So it is 3 by 6 whole power 5. And coming to the second case, 3 positive, 2 negative. So it is 3 by 6 whole cube, and probability of getting negative number is 2 by 6 whole power 2. But out of that 5, 3 positive, 2 negative, we can get anywhere in that 5. So interchanging. So first you get positive, next negative, negative, next 2 positive. That interchanging can be done in 5C3 ways. Total 5, in that 3 positive, 2 negative. Na? So this arrangement become 5C3. And coming to the last one, 1 positive, that is 3 by 6 whole power 1, 4 negative, 2 by 6 whole power 4, and we can interchange this in 5C1. To simplify this, denominator 6 power 5, and coming to the numerator, 3 power 5, 243, plus 3 cube 27, 2 square 4, 27 into 4, 108, 5C3 is 10, that is 1080, plus 3 into 2 power 4 16 into 3 48 into 5 16 into 15 240. Now numerator is 243 plus 1080 plus 240. This is 1080, 240 and 243. 3, 16, 5, 1, 1563 by 6 power 5. And simplify this one, we get 521 by 2592. And coming to next, the value of 3 into e minus 1 by e integral 1 to 2 x square into e power integral part of x plus integral part of x cube. The given limit can be written like this. First to take this part, integral 1 to 2 x square into e power integral part of x plus integral part of x cube. If x lies between 1 and 2, integral part of x become 1. That's why it is integral 1 to 2 x square into e power 1 plus integral part of x cube. Now take x cube is t, then 3x square dx become dt. Now the given definite integration I become, and coming to the limits, when x is 1, its corresponding t is 1. When x is 2, it is 8. X square dx, this become dt by 3, and this is e power 1 plus integral part of t. This is 1 by 3 into e power 1 plus integral part of t can be written as e power 1 into e power integral part of t. Integral 1 to 8 e power integral part of t dt. This is e by 3 into, now split this 1 to 8 e power integral part of t dt as 1 to 2 e power integral part of t plus 2 to 3, 3 to 4 like that. 1 to 2, its integration is integral part of t become 1, that's why it is e. So we can write this like this, 1 to 2 e power 1 dt plus 2 to 3 e square dt plus and so on, and the last 7 to 8 e power 7 dt. This is e by 3 into, this is e integration, after substituting limits it will become 2 minus 1. So this is e my plus e square plus e cube and so on e power 7. E plus e square plus e cube plus and so on e power 7 is in GP. First term e, number of terms 7. So this is e by 3 into e power 7 minus 1 by e minus 1. Sum to 7 terms in GP. A into r power n minus 1 by r minus 1. Now substituting this I here, the given definite integration become 3 into e minus 1 by e into I. I is nothing but e by 3 into e power 8 minus e, just taking this e inside, e power 8 minus e by e minus 1. So, this e minus 1, 3 and e cancel, finally it is e power 8 minus e. Now, coming to next. In the figure given below, area of the triangle OAB is root 3 by 3 square units. Find the value of b square minus a square. Observe this diagram. Area of the triangle OAB is half into base into height. Here base is a, height is b. So, that is why half into AB is equal to root 3 by 3. From this we get AB is equal to 2 root 3 by 3, or it is 2 by root 3. And if this angle is 30, this will be 60. Now, in this right angle triangle, tan 60 b by a, this is tan 60 is root 3. So, b is equal to root 3a. Now, substitute b is equal to root 3a here. We get a into root 3a is equal to 2 by root 3. From this we get a square is equal to 2 by 3. A square is equal to 2 by 3. And b square, substituting here, b square is 3a square, that is 3 into 2 by 3. Sorry, yeah, a square is 2 by 3, 3a square, that is 3 into 2 by 3, that is 2 b square. Now, b square minus a square, 2 minus 2 by 3, that is 4 by 3. This is the value of b square minus a square. Just area of the triangle formula, half base 8, half into base into height, and in this right angle triangle apply tan 6 to get two relations in a and b, solve them and get ab and substitute in that b square minus a square. Coming to the next question. Let P is a point on the parabola y square is equal to x by 4, which is at a minimum distance from the point 0, 33. Find the distance of P from the directrix of the parabola y square is equal to 4 into x plus y. First, you have to find out P. P is a point on the parabola that is at a minimum distance from 0, 33. So, let us take P is h, k on y square is equal to x by 4, and Q is 0, 33. First, tell me what is PQ? Distance. We want h and k, so that PQ is minimum, then only P is at a minimum distance from Q. PQ square is h square, h minus 0 whole square plus k minus 33 whole square. Since hk is a point on this curve, we have k square is equal to h by 4. K square is equal to h by 4 because it is a point on this one. So, from that h is 4k square whole square plus k minus 33 whole square. This is 16 k power 4 plus k minus 33 whole square. Now, to get k value so that PQ square is minimum, differentiate this and equate to 0. The derivative of PQ square dash with respect to k is 64k cube plus 2 times k minus 33. 64k cube plus 2 times k minus 33. For maximum or minimum of pq square dash, we have pq square dash is 0 for minimum or maximum. What you get here? 64k cube plus 2k minus 660. By inspection, k is equal to 1 satisfies this. When k is 1, this is 64 plus 2, 66 minus 660. And at k is equal to 1, what about its second derivative? I am going to check at k1 pq square is minimum or not. That is why I considered pq square double dash. This is derivative of this is 64 into 3k square plus 2. At k is equal to 1, pq square double dash is positive. That is why at k1 pq is minimum. At k1 pq is minimum. At k is equal to 1, pq is minimum. Sir, we need one slide extra here. ఒక వైట్ స్లైడ్ కావాలి ఎక్స్ట్రా. ఇప్పుడు ఇక్కడ ఇందాక ఎక్కడో ఒక చాట పెట్టారని ఈ క్వశ్చన్ పెట్టినట్లేరు అనుకుంటా. ఓకే ఓకే దే. సో pq is minimum when k is 1. So at k is equal to 1, pq is minimum. Therefore, point P is h comma k. When k is 1, substitute k1 here because hk is a point in this one. K1 we get h is 4. So P become 4 comma 1. Now what you want is distance from P to directrix of this parabola. Directrix of the parabola y square is equal to 4 into x plus y. Y square is equal to 4 into x plus y. This parabola can also be written as y square minus 4y is equal to 4x. This is y minus 2 whole square is equal to 4 into x plus 1. Now directrix is x plus 1 is equal to minus 1. So we get x is equal to minus 2 or x plus 2 0. Now distance of P from directrix is 6. The perpendicular distance from 4 comma 1 to this line x plus 2 is equal to 0. So here first you have to find out P, that is the point on this parabola and is at a minimum distance from 0 comma 33. So just find PQ distance. So minimize that so that you get P coordinates, and after that find distance of that point from the directrix of the parabola. And coming to the next question, let fx be a differentiable function such that 5 times f of x plus y is equal to fx into fy for all xy belongs to R, and f of 3 is 320. Then sigma n is equal to 0 to 5 f of n. From this relation, that is 5 into f of x plus y is equal to fx into fy. 5 into f of x plus y is equal to fx into fy. I am going to find f of 0 because we want the sum of f of 0, f of 1, f of 2 until f of 5. To get f of 0, put x, y both 0 in this one. Put x is equal to 0, y is equal to 0. Then we have 5 into f of 0 is equal to f square 0, f of 0 into f of 0. So, from this we get f of 0 5. Now, put x 0 y 1 in the same relation or x 1 y 0. We get 5 into f of 1 is equal to 5 into f of 1 is equal to f of 1 into f of 0. F of 0 from this is 5. So, from this what you get is f of 1 is equal to f of 1. Nothing you get from this one. Now, put x, y both equal to 1 here. Then what you have? 5 times f of 2, 1 plus 1 is equal to f square 1, f of 1 into f of 1. And now substitute x2 and y1 x2 and y1, this will be 5 into f of 3 is equal to x2 y1 f of 2 into f of 1. Given f of 3 320. So, 5 into 320 is equal to, from this relation f of 2 is f square 1 by 5, f square 1 by 5 into f of 1. This gives f cube 1, f square 1 into f of 1 is f cube 1 is equal to 5 square into 320. 320 you can write as 64 into 5. From this we get f of 1 is 5 into 4. F of 1 is 5 into 4, that is 20. Substitute this in this relation, we get f of 2 from this. F of 2 is f square 1 by 5. F square 1 25 into 2 power 4 by 5. So, it is 5 into 2 power 4. Observe here symmetry. F of 0 is 5 into 2 power 0. F of 1 is 5 into 2 square. F of 2 is 5 into 2 power 4. So, from that we can generalize f of 3 is 5 into 2 power 6 and f of 4 5 into 2 power 8 and f of 5 is 5 into 2 power 10. Now, substitute this f0, f1, f2, f3, f4, f5 in this, we get sigma n is equal to 0 to 5, f of n is f of 0 plus f of 1 plus f of 2 plus and so on f of 5. Na? Here f of 0 is 5, f of 1 is 5 into 2 square, and taking 5 common from the all the terms, it is 1 plus 2 square plus 2 power 4 plus and so on 2 power 10. Now, this is in GP. first term 1, common ratio 2 square, and number of terms 6. Number of terms 6. So after simplifying you get 6825. It is in GP na. Sum to 6 terms in GP apply here. We get this summation is 6825. And coming to the next one, number of normals of the given polynomial 3x power 5 minus 25x cube plus 40x plus 11 is equal to 0, which are parallel to the line x minus 20y plus 10. Given a curve, we have to find out the number of normals so that normals are parallel to this line. Nothing but the slope of the normal is equal to slope of this line. Slope of normal is equal to slope of given line, that is x minus 20y plus 10 is equal to 0. X minus 20y plus 10 is equal to 0. Slope of the normal is minus dx by dy. First of all, what is dy by dx here? 5, 3 into x power 5 derivative 5x power 4, that is 15x power 4 minus 25x cube derivative 75x square plus 40. This is dy by dx. So minus dx by dy become minus 1 by this thing. This is given as 1 by 20, that is slope of this line, minus x coefficient by y coefficient. So this gives 15x power 4 minus 75x square plus 40 is equal to minus 20. This is 15x power 4 minus 75x square plus 60 is equal to 0. Now we have 15 common. So it is 3x power 4 5x square plus 4. Now it is a quadratic in x square. Factorizing this, we get 3x power 4, this is 12 na? Sorry, dividing with 15 na? No 3 here. This is x power 4 minus 5x square plus 40. Now factorizing, it is a quadratic in x square na? It is x square minus 1 into x square minus 4. From that we get 4 values for x, 2r plus r minus 1 and 2r plus r minus 2. So the number of x values are 4. So we have 4 normals to this curve. Those are parallel to x minus 25 plus 10, 0. Coming to the next, the line L1 is perpendicular to the plane 2x plus 2y minus z is equal to 6 and passes through P 1 comma 1 comma 1. The minimum distance between L1 and the line r bar is equal to I plus 2j plus 3k plus mu into 2i minus j plus 3k. So you want a shortest distance between the two lines. Second line is given directly, passing point and parallel vector. First line, point given, and given that is perpendicular to this plane. Since L1 is perpendicular to the plane, it is parallel to the normal to the plane. L1 is parallel to normal to the plane. Normal DRs are 2, 2 minus 1. That's why the parallel vector to the first line is 2, 2 minus 1. So L1 passing through. One, 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 and parallel to the vector, and parallel to the vector 2i plus 2j minus k. This 2, 2 minus 1 are DRs of the normal to the plane. That's why L1 is parallel to this. Now, second line passing through 1, 2, 3 and parallel to 2 minus 1, 3. So, we have a formula for short distance. Here A bar is the point on the first line, that is I plus j plus k, and B bar is a parallel vector to the first line 2i plus 2j minus k, and the second line passing through the point I plus 2j plus 3k and parallel to the vector, say D bar, that is 2i minus j plus 3k. Now, shorter distance between them is mod box A bar minus C bar B bar D bar by mod B cross D. Box A minus C B D by mod B cross D. And coming to the numerator, this is det A minus C, these two, 1 minus 1 0, two minus 1 1, this is A, this is C, A minus A or C minus, you can write anything, 0, 2 minus 1, 3 minus 1, 2, and B bar 2 2 minus 1, and D bar is 2 minus 1 3 by, we want modulus of this one, and numerator modulus of cross product of the two vectors is I j k and B bar components 2 2 minus 1 and 2 minus 1 3. So, expand this determinant and this determinant and find that value of that determinant. We get, coming to this one, 0 into something minus 1 into 6 plus 2 8, that is minus 8, and plus 2 into minus 2 minus 4, minus 2 minus 4 is minus 6 into 2 minus 12 modulus by, and expand this determinant, what you get, I into 6 minus 1 5, it is 5i minus j into 6 plus 2 8j plus k into minus 2 minus 4 minus 6k, and its modulus is 25 plus 64 plus 36, square root of 25 plus 64 plus 36. So, finally, it is 20 by root 125, 20 by root 125, root 125 is 5 root 5 This is 4 by root 5. Or you can write as 4 root 5 by 5, the second option. Just to write the two lines and just apply the formula, short distance formula, and simplify that one. Coming to the next one, if the value of x satisfying the equation log of cot x to base cos x plus 4 times log of tan x to base sin x is equal to 1 is sin inverse root alpha minus 1 by beta, then the value of alpha plus beta. This we can write like this: log of given equation cot x is cos x by sin x to base cos x plus 4 times, and this tan x we can write it as sin x by cos x base sin x is equal to 1. And we know log of a by b is log a minus log b. That's why this is log of cos x to base cos x minus log of sin x to base cos x. Similarly, 4 times, again it is log of a by b formula, log of sin x to base sin x minus log of cos x to base sin x is equal to 1. Log of cos x to base cos x is 1, and if you take log of sin x to base cos x is some t, then it becomes 1 minus t plus 4 times 1 minus 1 by t. What is t here? Log of sin x to base cos x. I am taking log of sin x to base cos x as t, then it becomes 1 minus, this is t plus 4 into 1 minus, this is 1 by t. Now it is 1 minus t plus 4 into t minus 1 by t is equal to 1. This is t minus t square plus 4t minus 4 is equal to t. So you can cancel this t and that t. So we get a quadratic in t, that is t square minus 4t plus 4 0. This is t minus 2 whole square. So value of t become 2. And what is t? Log of sin x to the base cos x. Na? So log of sin x to base cos x is equal to t. T is nothing but 2. That's why this is 2. From this we get sin x is equal to cos square x. And write this cos square x as 1 minus sin square x. We get a quadratic sin square x plus sin x minus 1 is equal to 0. Sin x is equal to 1 minus sin square x. Taking that 1 minus sin square x this side, it is sin square x plus sin x minus 1 0. Now find sin x using the formula minus b plus or minus root of b square minus 4ac by 2a. Minus 1 minus root 5 by 2 is not in the range of sin x. That's why sin x is minus 1 plus root 5 by 2. Now x is sin inverse root 5 minus 1 by 2. So alpha become 5 and beta become 2. So alpha plus beta is 7. And coming to the next, if the coefficient of x power 15 in the expansion of ax cube plus 1 by bx power 1 by 3 whole power 15 is equal to coefficient of x power minus 15 in the expansion of ax power 1 by 3 plus 1 by bx cube whole power 15. Then we want mod AB minus 5. First, to get x power 15 coefficient in the first expansion, write the general term in the first expansion. TR plus 1 is 15 CR into AX cube whole power 15 minus R into 1 by Bx power 1 by 3 whole power R. This you can write it as 15 CR into A power 15 minus R by B power R. I am just separating the constant. Now coming to x power, this is 45 minus 3R minus R by 3. Here B x power 1 by 3 whole power R become x power minus R by 3. Now to get x power 15 coefficient, you have to equate this x power to 15. That will give 45 minus 3R minus R by 3 is equal to 15. So we have 30 is equal to, taking 15 this side, 3R plus R by 3. That is 90 is equal to 10R. From this we get R9. And substituting R is equal to 9 here, we get coefficient of x power 15. So coefficient of x power 15 is 15C9. 15C9 A power 15 minus 9. Substituting an R9, 15 minus 9 is 6 by B power 9. So this is x power 15 coefficient in the first expansion. And similarly take the second expansion and find x power minus 15 coefficient. So what is the general term in that one? TR plus 1 of the second one. 15 CR into, this is the second one, A x power 1 by 3, A x power 1 by 3 whole power 15 minus R into 1 by Bx cube, 1 by B x power x cube whole power R. This we can write it as 15 CR into A power 15 minus R by B power R into x power 15 minus R by 3, nothing but 5 minus R by 3 minus 3R. Now to get x power minus 15 coefficient here, we have to equate this to minus 15. 5 minus R by 3 minus 3R is minus 15. So 20 is equal to R by 3 plus 3R. So 10R is equal to 60. 10R is equal to 60. So R is 6. Now substitute R6 in this one, we get x power minus 15 coefficient. Coefficient of x power minus 15, 15 CR into A power 15 minus R by B power R. R is 6 here. Now given that x power 15 coefficient in the first expansion, same as x power minus 15 coefficient in the second expansion. So just equate these two. 15 C9 into A power 6 by B power 9. 15 C9 into A power 6 by B power 9 is equal to 15 C6. Here this is 6, this one. A power 9 by B power 6. We know NCR is equal to NCN minus R. Na? So that's why 15 C9 same as 15 C6. And taking this A power 6 B power 9 that side, we get A cube B cube is equal to 1. So from that AB is 1. What do you want actually? Mod of AB minus 5. Since AB is 1, mod of AB minus 5 become 4. So coming to the next one, A is equal to PQMN, a 2 by 2 matrix given, first row PQ, second row MN, and D is the determinant of the matrix A, and D not equal to 0 if det A minus D into adjoint of A is equal to 0, then which of the following options correct here? Here A is PQMN, a 2 by 2 matrix. What is this adjoint A? We know for a 2 by 2 matrix ABCD, adjoint A is D minus B minus CA. Here D is N minus B minus C A. This is adjoint A. And D is the determinant of this one. D is Pn minus MQ. Pn minus MQ. Now consider A minus D into adjoint A. A minus D into adjoint A determinant. This is A and this is D into adjoint A. Multiply, subtract these two. This is det P minus Dn Q minus plus dq. I am considering A minus D into adjoint A. Multiply this one with D. D is a scalar here. D into N, P minus D into N, Q minus dq. That's why it is plus dq. M minus dm and N minus PD. This is determinant of A minus D into adjoint of A. Given this is 0. Now find its determinant by using 2 by 2 determinant. AD minus BC. P minus Dn into N minus PD minus Q plus dq into M plus dm is equal to 0. And simplify this. Multiply these two. Pn minus P square D minus Dn square plus Pn D square minus, here take Q common, here M common, Qm into 1 plus D whole square. Here 1 plus D, here 1 plus D. Now expand this 1 plus D whole square and separate D square and D terms and the terms not containing D. This is Pn minus P square D, Pn minus P square D minus Dn square plus Pn D square minus Dn square plus Pn D square minus Qm into now 1 plus D whole square expansion 1 plus D square plus 2D is equal to 0. Now separate D square terms. This one we have D square, here we have D square. This is Pn minus Qm into D square, Pn minus Qm into d square. And coming to d, here we have one d term, that is minus 2Qm, here minus p square, because we are taking minus common, it is plus p square plus n square. So d square term and this is d term, and the term not containing d is Pn here minus Qm here, Pn minus Qm. And we know Pn minus Qm is d. So just replace Pn minus Qm with d. So it is d cube minus p square plus n square. Here I am adding and subtracting 2Pn so that we get p plus n whole square. 2Pn minus 2Pn plus 2Qm into d plus Pn minus Qm is also d. Now 1d we can cancel, given that is different from 0. So we have d square minus p square plus n square plus 2Pn become p plus n whole square, and taking minus 2 common here, it is Pn minus Qm. Pn minus Qm is d again. This d plus 1 is equal to 0. First cancel 1d, and after that add and subtract 2Pn to this, so that it is p plus n whole square, and this minus 2Pn plus 2Qm, if you take minus 2 common, it is Pn minus Qm, that is also d now. So this is d square minus of minus plus 2d plus 1 minus p plus n whole square is equal to 0. So d square plus 2d plus 1 is 1 plus d whole square, and taking this that side, it is p plus n whole square. So 1 plus d whole square is equal to p plus n whole square. Second option. So coming to the next question, if an is equal to minus 2 by 4n square minus 16n plus 15, and a1 plus a2 plus and so on plus a25 is equal to m by n, where m and n are co-primes, then m plus n. So write an like this: factorize denominator 4n square minus 16n plus 15, 4n square minus 16n plus 15, 15 4 60, 10 into 6. So you can write this as 4n square minus 10n minus 6n plus 15, and taking 2n common, it is 2n minus 5, minus 3 common, it is 2n minus 5. So finally it is 2n minus 3 into 2n minus 5. So an is minus 2 by 2n minus 3 into 2n minus 1. This can also be written as 1 by 2n minus 3 minus 1 by 2n minus 5. Taking LCM, denominator 2n minus 3, 2n minus 5, numerator become 2n minus 5 minus 2n plus 3, that is minus 2 only. This is an. Now we want a1 plus a2 plus and so on plus a25. No? a1 plus a2 plus and so on plus a25. To get a1, substitute n1 here. This you get 1 by 2 minus 3, 1 by minus 1, and when n is 1, this is 1 by 1. N is 1, this will become 2 minus 5, minus 3. This is 1 by 3 plus, coming to a2, substitute n2 here, this is 1 by 4 minus 3, minus n2 na, this is 1 by 4 minus 5. 4 minus 5 is minus 1. Because of this minus, it is plus 1. Plus a3. Substituting n3, it is 6 minus 3. 1 by 3 minus 6 minus 5, 1, plus and so on. And coming to a25, 1 by 25 into 2, 50. 50 minus 3, 47 minus 50 minus 5, 45. Now here minus this one and plus this one, plus and minus here. Finally, we left with this one and this one, that is 1 by 47 plus 1 by 3. This is 50 by 47 into 3. into 3, 120 plus 21, 141. So m is 50, n is 141. So sum will become 191.